Welcome to the High Performance Multifamily video series, presented by the Connecticut Green Bank as an extension of its monthly peer-to-peer networking group. That group was formed to gather diverse professionals working in the multifamily housing sector to share their knowledge of high-performing design and implementation. The video series continues that work. The Connecticut Green Bank is a quasi-state agency created to support the state's energy strategy to achieve cleaner, less expensive, and more reliable sources of energy while creating jobs and supporting local economic development. It's my pleasure to turn this presentation over to Lois Arena, who will talk about Passive House and scaling it up. Lois.
Great, thank you, Deane. Again, my name is Lois Arena. I work for a firm called Stephen Winter Associates. We have 3 offices in the Northeast. We're in New York, Connecticut, and DC. We're basically a consulting firm that deals with all of the environmental sustainable certification programs, as well as accessibility consulting and code compliance. My particular job is Director of Passive House Services, and my group focuses primarily on really large-scale buildings of all types, the majority of which, though, are multifamily. And I'm going to walk you through the basics of Passive House so that you understand the concepts and show you how they were applied to buildings of all types and scale. So the basics of Passive House are pretty simple. It's an energy standard. It's the most rigorous energy efficiency standard for buildings that exists currently. The good part of it is it's performance-based. So it doesn't require that the architect do some very prescriptive measures. We're not going to tell you you need to get to a certain R value for the roof or the walls. You have some play in your design. It gives you a lot of flexibility, so you can put a little more glazing here and offset it by a little more insulation on the other side. So it's a very flexible design tool for architects and developers. It basically gives you what I like to refer to as an energy budget that you cannot exceed, and it's per square foot of floor area. So it gives you a budget for heating, for cooling, and for the whole building energy use, which includes all the lighting and appliances in the building. And so with you, as long as you stay within that budget, you're going to meet your Passive House goals. The primary principles are on insulation continuity and reduction of any thermal bridging. And a thermal bridge is anywhere where we have a piece of the building that goes from inside to outside, penetrating through your insulation and your thermal envelope. So anything like a parapet that extends up the wall through the roof, any sort of a balcony that's poured in place that goes from inside to outside, those are typical thermal bridges. It also has a very high focus on mechanical ventilation, balanced mechanical ventilation. It's very important that all of the living spaces get fresh filtered air, and then all of your typical spaces like your bathrooms and your kitchens get exhausted. All the stale air is exhausted from those spaces. It also focuses on a very airtight facade. The requirements for airtightness for Passive House range somewhere between 5 and 10 times tighter than your typical energy standards or your codes. And the particular reason for that is that early on when the program was created, they wound up with some moisture problems in the building envelope because they didn't have this level of airtightness. And when they realized that the warm, moist air was actually getting in the wall and couldn't get out of these super insulated walls, they then imposed this air tightness requirement, which has solved any of those moisture problems. So the airtight facade is very important. And then high performance windows and doors to meet the comfort requirements, the air tightness requirements, and then the thermal envelope. There's a high emphasis on thermal comfort as well with Passive House buildings. So this is our diagram of how it applies to multifamily construction. Up in the upper left-hand corner, you can see we're pointing out continuous insulation and thermal bridge construction, and we've got a little arrows and our little dots that are pointing towards typical places of thermal bridges. And then your high-performance windows and doors and airtight envelope. High-efficiency lights and appliances are always required to help you meet that whole building energy budget. And in multifamily construction, lighting is a very, very large part of the overall building load because you have your common areas, your hallways, your stairwells where the lights are on 24/7. So controls and daylighting where you can implement them are very important. And then domestic hot water in a passive house building is also a very big part of the load, especially in multifamily. You've reduced your heating and cooling load so drastically because of your gray envelope that the domestic hot water actually becomes one of the bigger components of the overall building energy use. So finding ways to reduce the energy losses through the circulation system and the pumping becomes very important. So this is just a screenshot of all the different types of buildings that we are currently working on that are trying to achieve the passive house certification. They're actually going for full certification. In the left-hand corner, we have 425 Grand Concourse, which is a 26-story multifamily affordable housing project. The majority of the multifamily projects we work on, I would say 60 to 70% are affordable multifamily projects. So this standard, if you take anything away from this today, I want you to understand that the concepts can be applied to any building type, and you can use just about any construction method that you want to use and any facade type that you want to use to get to the level of passive house that the standard requires. So, but what I mean by that is you can use a brick facade, you can use a metal curtain wall facade, you can use a rain screen facade. We're dealing with those types of facades and the construction methods on across the whole spectrum of buildings that we're working on. So it's applicable. The devil's in the details. What we're going to help you do is with passive house, your consultant is going to help you design it in a way to minimize the thermal bridging and make sure that your insulation and your air barrier are continuous. And so we have on the lower left-hand corner some townhomes that are in Connecticut. We have several New York projects here. The upper left, the middle center, and the upper is a market rate in New York. The one in the center on the top, the smaller screen, you can see my cursor. I'm going to circle that one. That is actually a high-risk affordable housing project for homeless and veterans at risk, and that is in New York as well. This is the Cornell Tech market rate. It's not a dorm, but it's a student housing on Roosevelt Island in New York. To the right, this is a project in Boston, and this section here is 750,000 square feet of office space, and I'm going to go into these in a little more detail. And then in the lower center is an industrial factory in Sri Lanka. So I just want you to take away from these that any building type you can apply the standard to. So this is 11 Crown Street in Meriden, Connecticut. Again, affordable housing. The project consists of this apartment complex here with 50 plus affordable housing units in it, and then it has 15 townhomes to the right here. And what's interesting is when you're applying passive house to a larger project and a dense project like multifamily projects tend to be, you have more people per square foot, more appliances per square foot. So you have a lot of internal gain in the building. And what that does is it reduces the heating demand on the building because you have all of this heat. And so because the envelope to volume ratio is better, you have a more compact design, you have less thermal losses through the envelope, and you have all of these internal gains, it's actually easier to implement the standard on a multifamily building as far as the thermal envelope goes. You wind up needing less insulation, reduction in some of the requirements on the windows, and so it winds up being more cost effective to do it on a highly dense, large-scale multifamily project. Excuse me. Again, this is Betances. This is the one that I was speaking about just a second ago. That's affordable housing for at-risk and homeless populations in New York. Very small apartments, so very highly dense situation, under 300 square feet for some of the efficiencies. And what happens here is, even though it helps the thermal envelope come down in R value in thickness, you wind up getting a lot more people per square foot, a lot more refrigerators, a lot more stoves. So your whole building energy demand gets harder and harder to meet. Luckily, the Passive House Institute is implementing what they call an allowance for buildings that are highly dense. So they're coming out with a calculator that will help you increase the whole building energy demand to make it easier for these highly dense projects to pass the whole building component. You still meet the heating demand and the cooling demand, but the whole building component is what gets challenging the denser the project gets.
And are the plug loads included in the energy budget?
They are. They absolutely are. So we have assumptions for plug loads, the lighting, all the pumping energy for domestic hot water and any pumping for heating, all of that stuff. In one of our projects, we had vending machines. That all had to go in the model. We also have gym equipment a lot of times in these projects, and so that all goes in the energy model as well. Sendero Verde is a large scale, a very, very large scale affordable housing complex in Harlem. And there was an RFP from the city for this, and the community, the borough actually made passive house a requirement in that RFP. So anybody who bid on this had to bid it as a passive house project. And this is over 670 units, 850,000 gross square feet. And the first 4 stories of the project are mixed use podium. It's a mixed use podium. So there's a YMCA in there, and there's some retail, there's some community spaces. And you can choose to either keep them in the energy model or remove them and focus on the residential portions. And so, it's the call of the owners and the developers on how they want to handle that. For this project, we're just modeling and certifying the residential portions of this project. Now, it also applies to retrofit projects. We have recently been working with institutional institutions. We've been working with institutional clients that are working on a master plan for carbon reduction. They have these goals for their campuses, and they've come to us and said, look, we want you to give us a big overview of what we can do to our buildings, our existing buildings, to bring down the energy use. And we've been using what's called the EnerFit standard, which is the Passive House's retrofit track, to evaluate dormitories, office spaces, those types of buildings on their campuses to see how far they can bring the energy use down. A lot of times, what you're looking at is having to do this with the occupants in place. So that makes it quite challenging. And what you would do then in that case is do these retrofits in a phased manner, right? You would stage them. So if the windows are not at the end of their life and the walls are in good shape, as you can see, the brick on this assembly is in good shape, they're not ready to do any retrofit to the assembly. So the insulation on the walls, if they were going to wrap this building from the outside, would wait until the end of life for that facade. If the windows were at the end of the life, this would be a perfect time to go ahead and upgrade them to the Passive House standard. Dormitories in particular, this is a full dormitory, but it also has some kitchenettes in it, are very, very high energy demand. You almost certainly will not meet Passive House's energy budget, its normal energy budget for certification for a dormitory, because there's so many people per square foot. Everybody has a mini fridge, it's all that sort of stuff. So this is one of the building types that we will be using that calculator to come up with an allowance for this so that they could go ahead and pursue certification. This is a historic retrofit in Connecticut. This is 200 Tyler Street in East Haven. This has been a real challenge because of all of the historic requirements. We absolutely cannot touch the exterior of the building, so everything needs to be done on the interior. And again, there are pathways forward to do that with Passive House. They understand that there's the loss of square footage from insulating something that may not already be insulated from the interior, that you may not be able to get a Passive House level window performance in a historic looking window, especially in the frames, because the frames need to be so thin, the sight line needs to be so thin, and especially on anything that faces a street, Historic Society is going to be very strict about the look and maintaining the look. So this project is pursuing Passive House by doing interior retrofits. They are replacing the windows with something that looks very, very similar to this. There's not much deviation from what you see here. So this has been a very, it's a challenging project, but they're definitely moving forward. They're in demolition right now, getting ready to, and they just ordered their historic windows that were approved by the Historic Society.
Lois, in a project like this where you don't have a new wall, how do you deal with the moisture and condensation issues?
That's a good question. So we do a lot of thermal modeling, and I'm sorry I don't have a picture to show you that, but it shows you where the cold spots are. So every floor in this building is concrete, and it butts up to the concrete wall, right? So this is a CMU wall with a brick facade. So it butts up to that wall, and there's no insulation separating that slab. It's a very big thermal bridge. And so what we do is we model that connection in therm, and we look at how cold it's going to get. And what we can actually do is mitigate it from the underside of the slab by simply putting an inch or so of spray foam insulation up and under that slab. You come up the wall and under the slab for about a foot or two. It actually warms up the floor above enough. It's interesting the way the thermodynamics work of it, so that there will be no condensation on the upper portion of the floor. So you might not be able to meet the comfort temperature, like Passive House wants you to maintain surfaces that are no more than 7.5 degrees colder than the air temperature. That's not possible here, but we are able to mitigate any concerns of condensation.
Great.
So that was an excellent question. Thank you. And then I know this is a multifamily seminar, but I just wanted to also touch base on curtain wall facade. This is an office project. As I said, we're doing the middle section of this building. The first 4 stories are retail and restaurant. Then there you have 20 stories of office space where the building juts out a little bit, and then the top is residential tower. And this was also another RFP that we responded to. Office space uses a lot of energy per square foot, more than residential. And especially in Boston, they have so much office space. We thought in the RFP response that we would focus on the office space to make it an example of what is possible and how low you could get the energy use in typical office space. So that was a focus on this. And the challenge here is that this is a curtain wall facade. And anytime you have a panel system for your wall where the 2 panels come together, that creates a thermal challenge on how do you thermally break that and make it airtight. So we've been working directly with the curtain wall developer, the manufacturer, to look at those details, to make sure there's no condensation risks on the inside, and to make sure that we meet the Passive House criteria on this project. Office space has will have a different allowance and a different threshold than residential as well. So this will also gets calculated slightly differently. But here you have 1 person per 120 square feet, right? With a computer and, all of that stuff that goes with being in an office. So very, very high internal gains, very high whole building energy demand for office type use. And then this project was very fun. This is in Sri Lanka, very hot, humid climate. This was a manufacturing plant for textiles as clothing. It's a samples plant. This is where they make all the samples for clothing. And what we did was the attention in Sri Lanka obviously is to keep the heat and humidity out and to dehumidify the interior air. Those are the big loads on a project like this, with so many people working in the space and in such a hot, humid climate. There's no winter here. And so the focus was on reflective surfaces, overhangs, airtight facade, double pane windows, which is to them massive, right? They don't do double pane windows in Sri Lanka. And what was great about this is it's been occupied for more than 1.5 years now, and they're using 50% less energy than before, and they're using the same exact sewing equipment inside the factory that they did before the retrofit. So that's just to give you a little example of how, applying the concepts and really focusing on the whole building can really help you bring down your energy use and your operating costs. We, just a little aside, when we were in Sri Lanka, we stayed at a hotel that had single pane windows, and every day somebody had to squeegee the outside of the windows because condensation would form on the outside because you're cooling the inside, right? So the interior is cool, so that the glass is cool to the humid air, and so they would have to come and squeegee the windows so you could see out the windows, and they don't have to do it on this factory. So unfortunately, I think we put somebody out of work, but I think they'll find a place to work inside the factory. So that's my spiel on Passive House. Really the focus is, for me, that the concepts are what's important, and that it's applicable to any type of building, and you can use any construction method. It's just in the detailing and the pre-planning before you go into construction that's really important. Any other questions?
Yeah, no, terrific, Lois. That was a great presentation and summary. A lot of really interesting projects. So, did the loss of the necessary squeegee person and their labor costs fit into your cost-benefit analysis in Sri Lanka? No, only kidding. But I do have a couple of questions for you, and I think Kathy may have some too. Going back to the beginning, when you were talking about the density allowance that the passive house now or allows or incorporates, is that incorporated directly into the model that then transforms itself into the energy budget or that tests the energy budget? Is that how the density allowance is accounted for?
Right now they have an outside calculator. They are going to release a new version of the software in the fall that should include it at that point.
That should include it. Okay. And then a second one, can you go maybe back to the NYU dorm slide? So that's a very, very common condition in retrofits, and unfortunately, I think still in some new construction, that flat slab through the wall and out onto the terraces. It was interesting when you were talking about how to at least retrofit for condensation in the historic preservation one. But what do you do here if you can't get at the outside wall and put something over it from the outside? How do you address that massive, sort of egg crate thermal bridge that we're looking at there?
That's right. So that's the question. So we also looked at another one of their dorms that was a historic dorm that we couldn't do from the outside, and that one will be emptied. If you can't move the students out, you're really not going to do anything to the walls. You could possibly still do the windows, but you're not going to retrofit the walls, at least if you can't get them out on a floor by floor basis. If you can get them out of there and you are going to insulate the interior, you're probably only going to fur out the wall. Maybe 3.5 inches is probably all it takes to meet the underfit standard on a retrofit on the interior. And then you would do the same type of a thing, Deane. You would wrap up under that floor slab a little bit with some insulation to prevent the condensation at the corner. From the unit below, you do something. Well, I guess you do it in every unit. It affects the unit above. Okay. Right. All right, terrific. Now this one looks... Sorry, go ahead. I'm sorry, I was going to say this one looks a little more challenging because if you look at the window, it's right at the slab. Right. It looks like right at the slab. I'm not sure if that is actually the condition on the interior, but that's how it looks in this photo. Yeah, definitely. Okay, and then in terms of some of it looks like there's a pretty varied client base that you've been working with, and I know that some things are incorporated in, some passive house requirements are incorporated into RFPs, but what's your general feel for how the value proposition is hitting developers and owners, at least in our region, in Connecticut, New York, Massachusetts? Is the value prop getting across to them, and are they beginning to ask for this more and more? Is it still sort of a push-pull kind of situation? What are you seeing from the field? So we're seeing it being adopted by the states in part of their tax credit application forms. So that's why it started to take off in Connecticut. That first started in Pennsylvania, where I don't know if everyone is familiar with that program, where the developers use tax credits to fund affordable housing projects. And in order to get those tax credits, you have to meet a certain number of items on an application. Part of that application usually includes some sustainability measures. And Pennsylvania was the first to do this. They added passive house for an extra point. Now, those credits are very, very competitive. People go after those quite a bit. So the more points you can get on the application, the better. And that's what started the use of passive house on the QAPs and why it took off in affordable housing in Pennsylvania. And then that took over. Connecticut did that a couple years ago. So we're seeing multiple multifamily passive house projects under construction in Connecticut now. It's taking off in New York as well. Their housing preservation department there, HPD, is the one that puts it out. Now, HPD, and I don't want to get HPD is very cost conscious. They're all very cost conscious. So they're really making the developers show that the additional costs of passive house are minimal to none, and we're working with a number of developers to do that. But they keep coming back to us. We have several developers that are doing their third, fourth, and fifth passive house project now. They do see it as an energy benefit, and it's wonderful. What's also great is they're seeing reduction in costs because they're doing multiple now, and they've found ways to reduce the cost of doing this this type of a standard, just like LEED.
And when you're referring to costs, you're referring actually to first cost, not life cycle. Or I know it would work on the life cycle side, but are they actually beginning to get first cost down to comparable?
They're getting it to, I would say, the repeat ones are getting it to within 3%. I think some of them will tell you it's no extra cost for them. I think in general, some of them are getting the ones that are doing it repeatedly are getting it down to 3%.
Terrific. Okay. Well, that does it for my questions. Kathy, anything at your end?
Sure. Lois, you mentioned that part of the importance was in the pre-planning, looking at passive house and how it was going to be addressed. Can you say a little bit more about that?
Absolutely. When you do a passive house project, it's always an integrated design process, and that means that you have the architect, the owner, the consultants, your facade consultant, your passive house consultant, your MEP, and your CM at the table at the beginning of the project, understanding what it's going to take to do this. That winds up being the most cost-effective way forward. We review all of the drawings from schematic all the way through 100% construction documents, and we help them plan for reducing thermal bridges, the airtight facade. We review all the details. We work with the structural team to make sure that any thermal breaks we want to use on the facade, we'll work with their structural. The MEP understands the requirements and make sure we have room for our ductwork for our ventilation system and any other mechanicals that we have to put in, any controls on the lighting. So it all happens during design. And with the construction manager, the builder on board, they always are going to say, that's more expensive, can we do it this way? That's more expensive, can we do it this way? And that's one of the reasons why the costs are coming down, because we're getting this repeat input from some of our construction managers.
Awesome. And my last question is, I was really appreciative of how you broke out the elements of passive house, and particularly thinking about the domestic hot water systems, which are difficult to bring down costs for, particularly if there are requirements for continuous circulation. Can you talk a little more about the strategies that you're employing there?
Definitely. One of the big ones is the recirculation loop design. So minimizing the line lengths in the recirculation loop should be like number one design consideration. A recirculation domestic hot water system in these large buildings where it's running 24/7 can equate to about 40% of the energy used for domestic hot water in these buildings. It's a massive energy loss. So anything you can do to reduce those line lengths and reduce the pumping energy required should be number one. The next thing that should be looked at is repeat floor plans so that your risers and your taps are as short as possible. And so you're not having to run, keeping things, and this is very typical in multifamily design because windows are such short supply. The living spaces and bedrooms are usually on the exterior wall, and the bathrooms and kitchens are usually towards the corridor. But that helps to reduce line lengths and energy losses from the taps and things like that. So that's always a really good thing to do as well, is the stacking, similar floor plates that go up the building that help you reduce the piping required. That also is a first cost reduction. I know people always ask how much more does passive house cost, but there's a number of ways that we save the builder or the owner costs, upfront costs in this sort of an example, and then ongoing costs. I mean, they pay central domestic hot water, they pay, central ventilation and the lighting. So, we're always trying to pull those energy uses down, which will only help them with the building operation in the long run.
Great.
Okay, terrific. Many thanks, Lois. That was really terrific. More to come, everybody. This concludes this version or this installment of the High Performance Multifamily video series. We anticipate many more to come over time. Thank you for your time.